later. Okay, welcome everyone. My name is Łukasz Kuczera. I'm founder of Scalac. I'm here together with my team, Piotrek, another Piotrek, and there is Bolek and Mario. And we want to kick off Tricity AI community, and we have some cool presentations for you today. So a few words about our company. I founded Scalac 12 years ago. That's our main focus was Scala. After all this time, we decided to switch to our main focus to AI. So that's why we're here. I'm really glad that we have such a big attendance here. So quickly about the meetup. So we would like to bolster a community, and if some of you would like to speak on the next event, we'll be doing them. We don't have any schedule yet. Maybe we'll switch the place to accommodate more people. So yeah, let's hype, more practice, and I don't want to spend much time here. We'll talk about agents and LLMs here, and we have let's talk about Scalac.ai a little bit. So we work on current AI systems that are being developed. So currently focusing on sovereign AI, agentic systems, and distributed systems. So if you'd like to know more, we can talk after the presentations. And agenda for today, we have Mariusz talking about Google ADK, Piotr Kosecki, and Paweł Ściborski. And as I said, we have open call for speakers. And yeah, that's all from me. And I would like to invite, who's first?
Piotr.
Piotr? Okay. All right. So I'll give you the microphone.
Okay, so hello, my name is Piotr, and I'll be talking about local LLMs. A few words about me. So I'm really excited about the hardware. I work as a Scala developer, but I'm really curious about AI. And well, I did a few of small POCs that involve local LLMs, and I'll probably want to share them as my kind of case studies. So yeah, one thing about me which I didn't mention, I'm also studying criminology over the weekend, so that's just a fun fact that will matter here, because 2 years ago, on my first year, I had a subject which was called statistical criminology. In this, I had to prepare the presentation regarding what a link of the crimes against the property, meaning thefts and vandalism, with unemployment rate. So the main idea was that I should look into the statistics from police and from the main statistic unit. I don't know how to translate it. And basically, I had to calculate the coefficient, but I thought, well, I'm a software developer, and I should do something more advanced, more fun, because it was too easy for me. So I decided that I'll. So first of all, I found the page. It was called south.org.pl, which contains all the rulings, not all, but which contains rulings from the courts, it contains rulings from different courts, not only about crimes, but also civil courts and so on. So I've decided to use LLM to get from the API the ruling and extract the relevant data, like what was the paragraph, and to filter on the crimes against the property. But little that I know, when I started going through the rulings, the API, after 15,000 calls, decided that I have to pay over $600. And then I started looking for an alternative. Unfortunately, back then in 2024, at the beginning, there was no good model that would accommodate my needs, meaning good with Polish language and good with and which had a long context. So I abandoned this idea, but the seed was planted. So I always remember that I could get back to the local AI when it gets a bit better. So, and that's how I got into local AI. But now I want to give a short roadmap of this presentation. So first, I'll describe why I like local AI, why it's useful. I'll talk about hardware, about software, and in the end, I'll show my case studies, which are basically my POCs. And so, why we would want to run LLMs locally? First of all is privacy. We would want to, for example, lawyers, the lawyer firms sometimes don't want to expose their data into the external software. So running LLM locally in-house, it's sometimes demanded. And also predictable latency. How many of you saw, for example, rate limits and I guess unresponsive API, which for example, Claude or other coding agent. I have seen it plenty of times, so I feel like this could be an alternative. Regarding costs, hardware sometimes is expensive. We get there, but when we have high volume of data to process with LLMs, it gets better, and calculation goes over to the side of running local LLM and not using API. Other stuff is like we can use AI offline if someone wants this, and more ways to experiment. First thing to mention that what's important in running local LLMs, it's to separate two performance bottlenecks. One is prompt processing, prefill. It's the time when your GPU, CPU, or other kind of chip is doing computation about your prompt, and it's basically also is impacting the time to first token. And the second thing is token generation, or in other words, decode, which is basically how fast model is generating tokens for you. So the first one is compute bound. So your it means the faster CPU, GPU you're using, it will take less time. And token generation is mostly memory bandwidth bound, because calculations need to get to the different parts of the memory, and depending on how much memory and how fast memory you have, it takes longer. And also, context can kill token generation. So let's talk about with hardware. I separated hardware into like 5 categories, which basically I think 4 of them are user friendly or friendlish to run at home, and so let's start with consumer GPUs. And so consumer GPUs is basically a gateway drug. Here we see example of a RTX 5090, which is highest consumer grade model of the GPU provided by NVIDIA. Unfortunately, AMD or Intel, they don't have any consumer grades GPUs that can compete. But in the end, the bandwidth and the performance is great, but the 32 gigs of VRAM tends to be too low for running bigger models. But of course, you can put more than one GPU into your PC, as long as your CPU has enough PCI Express lanes and enough and your motherboard has enough of the PCI Express slots. Next level is workstation GPUs. Those are more or less consumer GPUs with more memory and a bit better chips. They are usually they have lower clocks. For example, GPUs like RTX Pro 6000 Blackwell in Max-Q 2-slot edition, they have lower clocks, so the temperatures will hold better. And yeah, the main difference between this GPU and the previous one is amount of memory, but it is a bit. It's important because bigger, larger memory, bigger model we can fit there. So this one is usually reserved for data centers. As you probably noticed, previous GPUs used GDDR7 memory, but those use HBM memory, high bandwidth memory. Exactly, that's the name of this memory. And well, it's directly soldered near the chip, and they don't use PCI Express directly there. They're using special SXM connectors. But as you can see, the B and GB models, they are apparently Blackwells, but that's not the case, to be honest, because there is, let's call it a tale of two architectures, because the architecture for the data center Blackwells is different than the workstation and consumer Blackwell. Main difference is that data center Blackwell has instructions for more instructions which can be used for writing CUDA kernels, but also it has tensor memory, which workstation Blackwells don't have at all, and has more shared memory, which is sometimes problematic when people try to migrate one kernel from the SM100 architecture to SM120, which also is counterintuitive. It would seem that SM100 should be subset of SM120. It's not the case. The other difference between them is that data center GPUs can support NVLink, which is very fast connection between the GPUs. But NVLink for the workstation GPUs was abandoned around A600, 6000 series of Quadro cards. So the other way to running LLM is, which got a bit more popular recently, is using let's call them PCs with soldered memory and unified memory. By soldered, I mean there you cannot extend the memory in any way because it's near the chip, and by shared memory, I mean that it's shared between GPU and CPU. So the first example is Apple Silicon in architecture, which was introduced with M1 CPUs, and because it's popular because the memory, the chips have really high bandwidth in comparison to other computers, even in comparison to PCs. It goes up to 800 gigabytes per second, and if and as we remember from one of the previous slides, it's really bandwidth is really important for token generation speed, but I think now the M5 CPUs get better with the they get better with prompt processing. But the next step is one more thing. In I believe macOS 26.4, Apple introduced possibility of using RDMA, random remote memory access. Yeah, remote memory access, or something like that. Basically, it's the way of avoiding TCP/IP stack to access the memory from the other computer. So latency between those computers is really low, and Apple is using Thunderbolt 5, which goes up to I think 120 gigabits or gigabytes. I'm not sure right now, but yeah, overall this allows clustering and running larger models. And if we go to DGX Spark, is NVIDIA's small computer, which is based on ARM chip, Grace Blackwell GB10, which is also not the real Blackwell. It has compute capability 121, SM121, which is basically a bit better than RTX Pro, but I'm not sure what's the exact difference. But by default, DGX Spark was sold, is equipped with the SPF connector, so really high speed, which can go up to the 400 gigabits. The last but not least is Ryzen AI Max computer. They're basically base computers. They also have soldered memory, and it's the AMD's way of trying to run models, but the only good thing we can say is that the community is pushing through and is also adding possibility of using RDMA on those chips, but it's a bit harder than on the other two, because those chips usually don't have those computers with those chips don't usually have PCI Express slots or any other way of communicating fast with other machines. So when you get, for example, from Minis forum the PC with kind of with a PCI E slot, you can put some better network card for this. And yeah, last on purpose is CPU only inference. CPUs are not that great for running models. Yeah, RAM is relatively cheap in comparison to HBM memory or other GPUs memory, but since last year it went up like crazy. The price is really high right now. What we would want to remember about this, the EPYC and Xeon systems, they have multi-channel memory, like 8 to 12 channel memory, which allows for running really big models, but they run them slowly. Also, for prompt processing, Xeon is better because it has some matrix instruction. I think AMX is responsible for that. And one thing also to note, NUMA layout. Basically, if you would want to buy Threadripper, there is this catch. If you think that if you look at the AMD's page, if you check the max memory throughput that CPU supports, it will show, for example, for 7000 series Threadripper somewhere around 300 gigabytes. But the problem is, it will show it for every CPU, but only the highest high-end Threadripper CPUs support this, because the bandwidth is dependent on how many chiplets are used for building the CPU. For example, 16-core CPU uses only one chiplet, and because of that, it can have only like 100 gigabytes of memory throughput, but the 24 and 32 core CPUs have like almost double. So that's it. And regarding software to run the LLMs, we've got like most basic, which is LM Studio. LM Studio is UI first inference software. It provides OpenAI and Anthropic compatible endpoints, and you can just download it, then download model, and just run it, as long as your GPU and CPU allows it. Ollama is similar, but it doesn't have graphical UI by default. So that's why I put it below LM Studio. And Llama CPP basically is the backend for both LM Studio and Ollama, but Ollama is not directly using Llama CPP. It's using fork of the Llama CPP. Regarding VLLM and EXO, I'll talk in the next slides. So VLLM and SGLang are like most production-ready LLM serving engines. They have various optimizations, and they can improve the multi-user usage because they scale really well with many requests. So that's the good thing if you are trying to run the LLM for the whole company or for multiple agents at the same time. Here we've got like most important things that actually matter with the LLM inference. So quantization basically allows you to make models smaller with increasing the speed of generation with a bit of quality loss. The other thing it basically reduces the weight's precision. The other thing which is kind of fresh, but the paper about this was introduced, I believe, it was published, I believe, last year by Google. It's TurboQuant. Basically, it's the paper about quantizing KV cache, which is important for the context, and which is with minimal loss. This I saw pull request with TurboQuant for Llama CPP, but I'm not sure if it was merged yet. MTP, meaning multi-token prediction and speculative decoding. MTP is, I believe it was merged last week to Llama CPP, which it really improves token generation because, as name suggests, it predicts multiple tokens at the same time. So that's one good thing for Llama CPP. And other parallelisms. Tensor, pipeline, and expert parallelism are mostly used by VLLM and SGLang for the models to split them across many GPUs. And those are different ways of doing that. So, the one thing I mentioned is EXO. EXO is mostly used for the clustering Apple Silicon based computers, but also there is a pull request which allows you to connect the, for example, Mac Studio and DJX Spark, which has really good compute power, but has not that good memory bandwidth. So, if you connect that, you can, in theory, you could have the best of both worlds. That the Mac Studio will take care of token generation, and DJX Spark will take care of prompt processing. It's still experimental and is at the stage of the pull requests. So when I watched the video about this, the person who managed to run told that he spent like 1 week to figure this out. So yeah, it's highly experimental, but it's good to know that something like this exists. So what can talk to local LLMs? Basically everything what supports OpenAI compatible HTTP API. So OpenClaw, which is maybe not is, it was really huge at the beginning of the year. Cloud Code, Open Code, Codex CLI, and other stuff. You can most of the stuff you can configure to work with OpenAI like compatible API. So let's talk about the state of the open models. So I didn't want to put too many benchmarks for this. I chose Artificial Analysis Intelligence Index just to show where are we regarding this. One thing to note, what's the difference between open weights and open source models? Open weights are basically just the weights of the model that are published for everyone's use. And open source would be if the company publish also training data, training scripts, and so on. So that's the main difference. And as you can see, on this index, open weights models are not far behind, maybe a few months behind the top tier models. So let's talk about my first project, which is good case study for using local LLMs. At some point, when my friend visited me, I wanted to show him a photo. And when I checked on my iPhone and tried to type the thing that I remembered about this photo, I couldn't find it. When I typed, for example, red car, it returned for me the photo of can of the Red Bull. So that's a thing that wasn't working. So I thought, well, maybe I can do something better. So I've created this kind of pipeline, which takes a photo, sends it into the vision capable LLM like Lava. I don't remember which one I was using. Was it Lava or Qwen 2.5 VL? I'm not sure right now. Then with that description, I went to the embedding model, also running locally, which created a vector of this description, and I stored it. And then I could easily, using cosine similarity, I could easily find images that match my my query. So that's the one case study for local LLMs. Second one is Lex GPT-PL. Also, as I mentioned at the beginning, I'm a criminology student, and criminology is about the law. So I thought maybe I'll build the AI assistant for the Polish law. So it's still in beta. It's mostly working, but I wanted to include all the rulings that I found in this SAOS website for my agent, so people can, when they find some paragraph or article, they can look for the rulings, court rulings regarding that. So, as I learned the hard way, parsing over 500,000 court rulings is not a good business decision to spend. When I spent over $600 for 15K of rulings, I decided to use local LLM. Of course, it probably took 2 or 3 times longer than it's supposed to, but I think my graphic cards paid themselves off with this. Last case study is my most recent POC. It's called Podcastoteka. As a criminology student, I went there because I liked to listen to the true crime podcasts. So I looked for the page when I can find cases, and based on cases, I could find episodes of different from different podcasters. And so I designed this kind of workflow for indexing this. It's not 100% local, but I'll describe why. So first of all, I'm downloading the episode that isn't in the database. Then I put the audio of this episode into the Whisper model running locally to get the transcription of this episode. Then, with this transcription, I went to the local LLM, which could extract the summary and most important data that I would want to keep separate for the information about the case. Then I went to the online embedding. I used online embedding because also I'm using embeddings for the search on the page, and because of that, I need to have the same embedding model, and running embedding model on a separate instance wouldn't be cost efficient. I think when I don't really have that many users. So that's why I used online embeddings. Then with these embeddings that I got, I used similarity search in my database, the same cosine similarity, which gave me which I took like 3 results. Then with those 3 results and original summary, I put it once again into LLM to check if any of those 3 matches the original one that I want to insert. If it didn't, I created new case. If it matched, I attached the episode to the existing case. And I don't have like that many episodes indexed, maybe 1,000 or more. But overall, I liked the workflow I created for this, and I found it really useful. So overall, you don't have to use always local LM or always API. You can use a hybrid approach, which basically, for example, in my LexGPT project, as I'm using agent, I'm not running a separate model. I'm also using for my agents, I use the LLM API from, I believe, Gemini. And that's one thing. And you should ask yourself a few questions. Should you run it locally? So those are questions that answers can help you with. So if your data is sensitive, if you have a lot of data that you can put at once into the LLM, which can then when your GPU can work overtime all the time, it will pay for itself. But if you need frontier models like Gemini 3.1 and GPT 5.5, it's you usually should choose API. Okay. Also, what are main problems with the local LLMs? It still can hallucinate. It doesn't matter if it's local or if it's online, it can still hallucinate. Sometimes also the model licenses are different, and you need to check them if you want to use them in production. Other issues are like mostly configuration issues that you need to check, and the results that you need to benchmark if they are if they are good enough for you.